Hi guys, in this tutorial we're going to make a simple noise effect and add it to an image. What we have here is a screenshot of my desktop. You can use any image you want, and this is going to be our source image. Place it in the same package, which I call noise, which comes under algorithm package that already existed for the traversal tutorial stuff. Right, so what we have currently is our noise app that extends JavaFX application, so the normal stuff, create content, have our pane as the root node. We're loading our image using resource and then pointing to the place where the image is and using its external form so it's easier to load for JavaFX. And apart from that, everything else is exactly the same. Right, so we've loaded our image. And as you know, we can sort of refer to an image as two-dimensional array with pixel colors. And this is exactly what we're going to do now. We're going to obtain colors of each pixel of that image, and then we're going to modify them slightly to create some noise. Most of the time, you would probably want to reduce noise rather than create, but sometimes it is actually quite interesting to just see what kind of effect it's going to have. For example, if you're doing an image editing software or some sort of horror game, then you might add noise to an image or even animate it if you're using if it's a game. Right. So what we need now is let's do apply noise and then draw, I think. We first need to obtain pixel data, so we'll probably need to pass that in so we know what we're doing. Image. We need pixel data, so we're going to use pixel reader from that image, and we'll probably produce another image. If I rename this to original, and then this returns another image called modified. And then we draw, well actually we can then create image view, new image view, pass modified image as the data. Would get children at image view. Or in fact, we could have added horizontal box with the original image as well. Yeah, so that we could see, sort of place them side by side and then see the difference. Right, pixel reader, we need to have writable image, so we can write to that. This is source, new writable image. We need to make sure we have exactly the same dimension, so width and height. What's it saying? Right, we need to convert to integers. Get. Yeah, in fact, it will be easier because we'll need to loop through each pixel y and height for x and width. We first obtain the color, and we do that by obtaining by calling pixel reader get color x and y. So this gives us the color of the pixel at position x and y, so we have to then modify it. Noise value is going to be a random value and then make it smaller, divide by 3, actually divide by 5, and then we'll see how that works. Color, we then need to change the color. I think color is immutable, so I'm going to create new instance, new color. Which is essentially so it's going to be red of the original color plus the noise. So what we're doing here is essentially making very small change to the red, green, and then blue component of the pixel, of the color of the pixel, which changes the color of that particular pixel. But we do that for every pixel in the image, and we then get, or should get, some noise in the image. It's RG, so it's green plus noise. And we need to remember to truncate this to, or clamp it to the value of 1 as being maximum, because noise, when we add this value to the color, to the original color of the pixel, we might get a value that is greater than 1. And the color constructor simply won't accept it. Blue plus noise, 1. What's it expecting? What? There must be a public constructor. Alright, it's also expecting opacity 1, meaning completely not transparent, so it's fully visible. Right, so that is a new color. Do we have our pixel writer? Pixel writer image, pixel writer. So we've constructed a new image, and then we've obtained reference to its pixel writer, which allows us to write pixel directly to the image. And then we simply set the color. So we do the reverse operation, essentially. And that should be it. We now return our modified image. So we went through each of the pixels, obtained color of that pixel, generated random value for a noise, added that noise, and made sure that the value isn't greater than 1. It cannot be, we don't have to check for 0 because that value is positive. The return value is going to be positive, so positive plus positive will never give us a negative value. Apart from that, everything should be fine. Red, green, blue is RGB, and the opacity. Right, let's run this and see if that works. Yeah, I don't have screen large enough to show both of them, but this will have to do. So yeah, I'll just remove that. So as you can see, there is some noise. In the image. This was the original image, and that is a modified version of it. You can also control the value of noise by setting this to some other value. So what you want to do is by decreasing that value by which you're dividing, you're making noise bigger, essentially greater. So there will be a lot of noise in the image. If you make it greater, so essentially making the whole value smaller, then you'll get sort of better looking image because the noise will be, the value of the noise will be small. So you can If you want, isolate this into some sort of method which takes a noise value and then returns whatever you need to return, whether the image or the image data, and then sort of work with that. Like I said, this could be used in an image editing software or a horror game, I suppose. If you create an animation timer and then use that in a loop, like creating the noise value, but changing it every time, then what you'll get is essentially image where everything is kind of changing every time because the noise value will be different every time. Although the original image stays the same, these values will change and therefore the whole image will change. And that is it for this tutorial, which was rather short. Thanks for watching.